Doing is I'm asking that you guys use what I'm calling an algebra jig. Basically, if you think about it in terms of like woodworking, a jig is something that you would reuse over and over again to like replicate cuts. Let's say you had to cut a bunch of banisters for a railing, and instead of measuring out 37.5 inches each time you go to cut something, what you would do is you take a 2x4 and put a little stopper on it, so that way that this distance here is what you need it to be. So that way when you put the other piece of lumber in here, when it sticks out, you just cut it right there. You don't have to remeasure it. So you're reusing something to make your life easier. It's called a jig. Have you ever heard of that? It's a super, it's a nice thing to use, especially if you ever do like framing or anything like that. But I use this thing called an algebra jig for this, and it's completely different than what they show in the books and whatnot. I've had some pretty good success with it throughout the years. That no matter what, every single time you have an isosceles right triangle, it always falls in this pattern of what we call 45, 45, 90. Across from the values of 45s are both the same. They're both x, because remember, it's isosceles. Across from the base angles are always the same side lengths. And then across from the 90 is this value of x times the square root of 2. But it doesn't mean that every time you see this, there's always going to be a root 2, because sometimes there isn't. For example, I don't see a root 2 there, do you? I just see an 8. I think I know where you're going. Here's what you do. You do the same thing every time. Across from which angle do you know? We know across from the 90. Very good. I know across from the 90. Across from the 90 is equal to 8. So that means something times the square root of 2 equals 8. How do you undo multiply? Divide. So in your calculator, all you have to do is this. Take 8 divided by the square root of 2. And that gives you your missing value. You have 4 root 2. So that means that the value of x is 4 root 2. So everywhere else you see an x, you put
4 root 2.
4 root 2. And if you think about it, if x is 4 root 2, that means across from the 90 would be 4 root 2 times root 2. What's the square root of jump times the square root of jump? So what's root 2 times root 2? 2. What's 2 times 4? And that's where this comes from. It's a one-step algebra. That's it. That's all it is. That's all it is. If this is 18, it's 9 root 2. The other sides would be 9 root 2. All you're doing, quite honestly, if you know across from the 90 and it doesn't have the root 2 in it, just cut it in half and slap a root 2 next to it. No matter what. No matter what, it works. If it's 13, well, what's half of 13? Root 2. Done. That's right. If that's 13, in my calculator, well, I'd write this out. In my calculator, what's great about these multi-view calculators, if you type in the calculator 13 divided by root 2, it's going to tell you, you get 13 root 2 over 2. And that's what we call a simplified radical form. It's rationalized. There's no square root in the denominator. That calculator does it. You press a button. That's it. That's so important that you guys have that calculator for second semester. I have plenty of them. If you need to buy one, so we still have them. Okay? You really, really, really need one. Okay? Excuse me. Let's try another one. See how I had the tick marks for the side lengths showing that it's 45, 45, 90? The other way you might see it is this way. Because if the base angles are the same, what do you know about the side angles? Or side angles? The sides. The sides are the same. There's just two ways that you might see it written out. So let's say this is 5. What are the missing side lengths? Again, you know across from what angle? I know across from my... So the value of x is 5. So what's across from the other 45? 5. What's across from the 90? You look like you're really worried. You okay?
You always say this like early class.
But you have that look of...
Oh, just thinking.
Oh, is that where the smoke was coming out your ears? But yeah, hey guys, I'm trying to make this as unbelievably straightforward as you can get to, because quite literally there's nothing to this. It's just a matter of understanding where you are on the triangle to know what you're across from. If you know what you're across from and you can write this out each time, solving for x solving for all the side lengths is super fast. Okay. There's another style, and that comes from equilateral. If you have an equilateral triangle, what do you know about those?
All sides are equal.
Yes, all the sides are the same.
The exact.
If you equilateral, what do you know about the angles?
They're
all
the
the
same.
Do you know what they measure? 60.
60 degrees.
They're all 60s. All right. So let's say they're all 60 degrees. Let's just pick a side length then. Let's say this is 12. That means this side is, and this side is
12, of course.
Okay. Now, if I draw an altitude, remember an altitude goes from a vertex and it's perpendicular to the side across from it. If I draw an altitude, it's actually the perpendicular bisector of that side, which makes those two base pieces how much? 6. 6s. Good. Now, if this is 90 degrees, this is 60 degrees, how much is left for up there?
60.
30.
Oh, because it's split.
Now you get what's called a 30, 60, 90 triangle. And what I want you to look at there is notice the difference between the side. Yes, sir.
How'd you get to 30?
When you draw the altitude down, it's going to create the right angle here. Okay. If I have a right angle here and 60 degrees here, how much is left for this angle here? 30. Has to be 30 because these three angles have to add up to equal 180. Does that make sense?
Yep.
That's where it's coming from. Okay. So look at the relationship between across from the 30 versus across from the 90. What's the difference between 6 and 12? It's half. So you double it, right?
Yeah.
So across from my 30 is x. What would be across from the 90? 2x. Okay. But now we got to figure out what to do for the across from the 60. So we go back and use the diagram there. Let me split the screens here. So we have 6 squared plus something squared is 12 squared. What's 6 squared? 12 squared. Okay, so we have 36 x squared. Subtract that over, I get x squared is 108, I believe. And now how do you undo squaring? What's the square root then of 108? 6 root 3. What did we do to that value of x to turn it into 6 root 3? We multiplied it by what? We multiplied it by root 3. So you get the pattern. Again, it's nothing more than setting yourself up for a, at most, one-step algebra problem, depending upon what side length you know in that triangle. So 30, 60, 90, it can be written out a couple of different ways. It might just give you a 60-degree angle in the 90, or it might give you the 30-degree angle in the 90. Whereas the 45s, it gave you either sides like this, or it showed that it had base angles that were the same, like that. Either one of those means the same thing. Okay. Again, it's a matter of where or what value do you know across from which angle. Set up the jig, figure out what x is, and just substitute back in. It is absolutely nothing more than a one-step equation for any of these. For any of these. I'll show you. Excuse me. So, with this example here, by giving you guys the 30 and the 90, that means it has to be which of the two? Is it a 30-60 or a 45? 30-60. So you write it out. 30, 60, 90. What's across from 30? It looks at an x. It looks at an x root 3. It looks at a 2x. Which value do you know across from?
90.
So which one of those do I use to solve for x? The 30, the 60, or the 90? The 90. This has to equal how much?
No, 5.
This has to equal 10,
Oh.
which means my value of x is 5. So if x is 5, that means across from the 30 is,
5.
across from the 60 is,
5 root 3.
see how fast this is? And like I was saying, that's where this is going to come from. 30, 45, 60, 90. 30 was at 120.
Oh, these are angles? I thought this was just an asterisk.
No. No. What happens here is that all of these angles are called what's called a reference angle. It comes up 30 degrees here, it comes up 30 degrees here. The ordered pair here, well, I drew it really badly. They wind up having the same ordered pairs with different signs, S-I-G-N, positives and negatives. This idea of knowing how these two triangles work, these 30s and 30-60s and the 45s, allow you to do all of this in Algebra 2. It's a matter of, can you draw it, can you place it, and can you figure out what's missing from just knowing one side length. This is one of the biggest things we talk about this entire school year, is getting this down. Uno. Take a minute. Solve for all the missing side lengths for those two triangles. Please.
Oh, since you guys nice.
Excuse me. Grab sake of time here, let's see how we do here. So on the first one, you know that's got to be 45, 45, 90 because the base angles were congruent. You know across from which angle?
90.
You know across from the 90. So you set the x root 2 equal to 11. In order to solve for x, you're just dividing both sides by,
2.
not 2, root 2, good.
And then gave it your 11.
And you get x is 11 root 2 over 2. So your other sides are 11 root 2 over 2. What's that?
I said,
It seems like it should be a lot more difficult than it is, but if you just keep in the mindset that the most work that you have to do is write this out to figure out which one you are across from. The calculator does all the other work. It really does, and that's what's nice about it. Right? On the second one, you knew that it had to be 30, 60, 90 because of the 60. It's kind of convenient. You have to have some info. Again, you write it out. Excuse me. Do you know why I use arrows?
because it shows that.
Exactly. I use arrows for that because it's showing you what you're looking at. The 30 is looking at x. The 60 is looking at the x root 3. It's pointing to the direction that it's looking to. Okay. That comes into play probably by the end of this week when we start talking about SOHCAHTOA. All that fun stuff.
Yeah.
So we know across from the 60 is 18. When you solve that quick one-step equation, all you have to do is take 18 divided by the square root of 3, and what'd you get? She stole yours.
I was like,
Yeah, 6 root 3. So that means the value of x is 6 root 3. So that means across from the 30 is,
6 root 3.
and then across from the 90 is going to equal 2 times that. 12 root 3. And it just keeps going on and on and on from that. Not terrible. I got a dozen of these for you to do tonight. Now, you guys will have that start on it. I cannot stress enough of writing out those two little algebraics on the top of the page and then just reusing. The more you reuse it,
No, she's like useless.
the more you reuse it, the less likelihood you are going to need to screw something up. I mean, I wouldn't put it past you, but you'd be less likely to screw up.
Yeah. Oh, I get drunk.
So, again, as you're getting these things as they're moving their way forward, I cannot stress the importance of how these things write out, how we set them up, and solving them through, because you're going to use this skill a ton second semester, as well as a ton as you guys get into Algebra 2. No matter which level you wind up at, the trig unit is one of the biggest things that we see. Also, what happens a lot of times with this unit, with these special right triangles, you're going to see special right triangles in just about any of the shapes that we go through from here on out. We're going to see special right triangles hidden in circles of all places. Yeah. We see special right triangles mixed into polygons. We start talking about perimeter F, stuff like that. And from there, all right? So please, work on these. Like I said, there's only a dozen, there's 6 of each style. You're gonna solve for all the missing side links. And I think it's spaced out nicely enough that you can write down your algebra parts each time and just continually solve. And like, what's that? Yeah. I honestly don't, how fast you guys went through that, I don't think this is gonna be all that bad for you, which is good. Okay? Questions on this so far? I mean, granted, it does get more complicated later on, but to start with, I try to make sure it was really, really, really easy. You guys all know how to type those fraction things like that in your calculators, right?
Yeah, the U over the D, whatever.
Yeah. N over D?
N over D, whatever.
Because I know, for example, there's one where because they give you this one. This one's really kind of weird. So this is number 10. Number 10, it tells you you have a 30, 60, 90 because it gives you the 30 and the 90. And you know that you're given across from the 30 is 4 root 3 over 3. Which means I have to know how to type that into my calculator to substitute in for x. So basically all I'm doing is this. I'm going to make a fraction bar. And I type in 4 square root 3 over 3 times square root 3. And it gives me an answer. And that's what's across then from the 60. Because it said 4 root 3 over 3 times root 3. And it gives me 4. If I go back to it, instead of multiplying it by root 3, I can multiply it then by 2. I think my calculator is going to give me a decimal. Yeah. Yours will say 8 root 3 over 3. It should. Okay. It's just going to be a good practice for you guys to get reaccustomed to how your calculators work and how you type these things in. Make sure you use fraction bars on these things as you're doing them, okay? Does anybody still need to buy one? I have them. Do you have it on your money on you, or?
No, I just did it like.
Okay, that's fine. That's fine. What you can do then, when you do it working through stuff, Austin, you can just set up your algebra jig itself. And if you, at least if you set it up, you don't. If you do that, if you don't have the calculator on you, you can press the calculator button later. You know what I mean? So you can set all this up. Just press the buttons later if you want. Yes, sir. Because it goes across the 60 forward over 3 multiplied by 3. You better
She believes it.
Congratulations.
She does. I love her.